Just the word earthquake is enough to bring to mind images of terror. But most of the work being done around the world to cope with the problem is directed to the protection of property. Here is the story of one innovative and practical program to protect people. It shows what can be achieved when people cooperate in peace. This record of Project Reconstruction Saighanchi is dedicated to those who made it possible. Syed Sibtain, Asta Olesen, Alan Kong, Johan Mortelius, Gorm Pedersen, Jørn Funk Nielsen, to the Australian, Danish and Dutch agencies which financed the project, and to the villagers of Saighanchi, Afghanistan. March the 21st, 1976, New Year's Day in Afghanistan, an earthquake measuring 6.8 on the Richter scale struck the Khum region of northern Afghanistan. Some 50 people died, many thousands were injured, and more than 1,000 homes were destroyed. Right at the epicenter of the quake, close to the Russian border, was the village of Saighanchi. It was totally destroyed, though no one was killed. When Australian architect Syed Sibtain and Danish anthropologist Asta Olesen visited there 6 months later, the 25 families were sheltering in tents among the patched-up ruins of their houses. It was agreed that the village should be rebuilt, and it was, using a new earthquake-resistant building system which combines modern technology with traditional skills, using local or readily available materials. It took about 16 months, spread over 3 years, because no work was possible during the severe winters. Syed believes that the process used to achieve the goal is as important as the goal itself. The project was concerned with people just as much as with bricks and mortar. So the presence of a social anthropologist was just as important as the presence of an architect. The lifestyle of the people would be improved, but not altered. The houses certainly had to be socially and aesthetically acceptable to the people who would live in them. The basic needs of the people would be fulfilled, and crucial to the whole program was the design of the building itself. Walls are built using the load-bearing characteristics of the arch. Built in this way, the walls during seismic stresses are able to stay intact very much longer than normal straight walls. But if they do eventually fail, they will fall one way only, outwards. The traditional nomadic tent called a yurt served as a model for the roof, which is separate from the walls and independently supported. The components are put together in such a way that the roof structure looks like an inverted basket when used for small structures such as houses. Under stress, the whole dome stays as one. A 1:5 scale model was constructed and tested on an earthquake simulator. It withstood seismic forces greater than the most violent earthquake yet recorded before parts of the wall began to come away, outwards as anticipated. That was the theory, and the theory proved. So let's look in more detail at how the Saighanchi project was carried out. Of course, it can be repeated elsewhere in any country where a domed style of building is acceptable. For other areas, the design could be adapted. The footings are built first, then the structural frame of the roof is erected. 8 members go to the apex. At the springing point of the roof, there are 4 wires to distribute the seismic force throughout the whole structure. The roof joists are added. When the walls have been erected, the roof is covered with wooden planks or reeds or branches. A plastic waterproof membrane is placed on strategic places on the roof before it is rendered with cargill, a mixture of mud and straw, to provide a surface impervious to rain and snow. The walls are rendered with the same materials. In order to make the community self-reliant, the villagers were trained in all building skills, from the steel structural components to the bricks and concrete blocks and everything else used in the village. Steel structural members were heated until red hot and bent to form. Of course, the structural components can also be fabricated in wood, where good quality timber is easily and economically available. An attempt was made to make enough bricks in the village, but the labour force proved too small. Of the 153 people in the village, only about 20 men were available for work on the project. The rest were either too old or too young, or had gone away on military service. So the switch was made to concrete blocks. This certainly speeded progress and helped to show the flexibility of the system. Later, mud bricks were made on the site, in their thousands. But kiln-burnt bricks were bought. The two were combined in the construction of the walls. The project began with the construction of the public buildings, the mosque, of course, being the first. The mosque, as finally completed, has an evaporative cooling system, which is an improvement on a traditional system. The tower beside the mosque is surmounted by a wind catcher. The hot wind passes into this wind catcher and down through the pipe, which stands in a pool of water. Here it is cooled before it passes on through a concrete pipe tunnel leading into the centre of the floor of the mosque. Alongside the mosque were built a school of 2 rooms which can accommodate up to 48 students, a teacher's house of 2 rooms, and an office for the credit union to which all the families belong and which serves also as an office for the cooperative. At the end of the first year, all the public buildings had been completed, as well as 8 other rooms, 13 rooms in all, plus the mosque. This meant that the 13 families still living in tents were able to move inside during the winter. The total village is located at 2 basic levels, the higher one where the public buildings are situated being about 12 metres above the rest of the village. In the spring of the following year, 1978, work began on the clearing of the ruins of the old village to make way for the construction of the rest of the new village.